Well, good morning or good afternoon, depending on whether you are east or west of me here in Dallas. Thank you for joining us for our latest webinar in our series of vertical webinars. This webinar is CBRS Alliance breaks down the connectivity barriers in transportation. Go to the next slide for me, Josh. Have a really good lineup of speakers with us today. I'm very pleased and excited by the panel that we have and looking forward to hearing from them. Also, just want to make everyone aware here that by joining the webinar, you agreed to the terms of the CBRS Alliance privacy policy and the webinar disclosure located in the event description. This session is being recorded for the CBRS Alliance's use and distribution. So if you have colleagues, et cetera, customers, whomever, that would like to have access to this information, this will be available in a recording on the CBRS Alliance website. Next slide, please, Josh. So first up, I'm going to introduce our speakers. Myself, of course, Alan Ewing, Executive Director of the Alliance, and I'm now closing in on starting my third year, I guess, or closing in on my third year with the Alliance. The CBRS Alliance, of course, now is 176 member companies, which is quite remarkable. And of course, everything we're doing here is, and I'll be going into a lot more detail, is really about LTE and 3G PP-based 5G and R as an evolution, those technologies in the CBRS band. So shared spectrum, of course, is the key element here. With us today, my pleasure to introduce some really great folks and people that I've enjoyed working with now as part of the Alliance. First is Steve Wimsett, who is the Senior Director of Business Development and Alliances with Commscope. As the Senior Director of Business Development and Alliances for Commscope, Steve leads CBRS initiatives, including the CBRS Specialist Channel Program and ecosystem partnerships with key EPC and solution partners. He joined Commscope via the Aris Ruckus acquisition and previously led Smart Cities, TBWS, and strategic alliances at Ruckus. He currently is a Vice Chair of the CBRS Alliance Business Working Group and has been actively engaged in the wireless market for nearly 20 years. So looking forward to Steve's presentation. Next slide. Our next speaker is Yunus Shaddad, Executive Director of Enterprise Sales and Business Development for Ericsson Networks. Yunus is driving a cross-functional team to solve indoor connectivity needs in the enterprise space. Previously, Yunus headed indoor sales and for global customer unit AT&T, where he established Falcon, the indoor program. Prior to that, Yunus headed services business development for accounts like T-Mobile, AT&T, and Sprint. And he was also responsible for project management and RF engineering with 2 patents. Yunus has been with Ericsson for 23 years and holds a bachelor's degree in electrical engineering from Southern Methodist University in Dallas, Texas. Welcome, Yunus. Next presenter is Dr. Derek Peterson, CTO of Boingo Wireless. Derek is the Chief Technology Officer at Boingo. He is responsible for Boingo's technical vision and strategy, and under his leadership, Boingo is pioneering the adoption and deployment of the latest wireless network technologies, including 5G, CBRS, Passpoint, network virtualization, and convergence. Dr. Peterson is a CBRS Alliance and Wireless Broadband Alliance board member and a founding member of the Wireless Infrastructure Association's Innovation and Technology Council of wireless industry leaders. He is a veteran of Operation Desert Shield Storm and Operation Joint Endeavor, serving with the United States Air Force. Welcome to Derek. And next slide, please, Josh. So our agenda today is doing the welcome, of course, now. I'll be talking a little bit about what OnGo is and CBRS in general. Then we'll move through with our various panelist presentations, talking about the connectivity challenges in transportation, how OnGo can be part of that solution, and how you can get started. And we'll also have time for Q&A. 2 things I would like to mention, and it may be on the next slide, but just in case it isn't, there is an opportunity to ask questions during the webinar. There is a questions panel or questions item in your control panel. If you type in your questions, we will see those. I will curate the questions and pass those along to our panelists at the end of our session. So please feel free to drop those in. Any questions we don't get to live, we will make sure to capture in text, and we will include a Q&A response section as part of the materials that will be uploaded here. In addition, on the panel, you will see a handout section. So there is a one-pager regarding the transportation vertical. Please feel free to download that. That's something that you can have as a piece of collateral to refer to now and later. So with that, let's go on from there. Look like we've handled the Q&A. So what is OnGo and CBRS? So this is my part of the presentation for you. So a little history first to get started with. Really everything begins back in 2010. And that's when NTIA identified this particular band, 3.5 gigahertz spectrum, what is now known as the CBRS band, for potential shared use. Work then proceeded with the FCC, Department of Defense, and others to determine how this, what kind of framework, what kind of structure should be implemented, and the rulemaking was done going through 2014. 2016 is really where CBRS Alliance, the middle of the year, was born, and started with just a handful of members, growing, like I said, to now over 170 members today. So this is really dedicated, what we're doing here in CBRS Alliance, dedicated to using 3GPP-based technologies in the CBRS band. The OnGo brand, which we'll talk about briefly at the end of my section, was also launched in 2018. And OnGo is really the brand name of 3GPP-based technologies in the CBRS band. So when you talk about OnGo, you're talking about anything LTE, 5GNR in our band. The specification development, the baseline specifications, 2018. 2019 is when things really began to get real, and including the initial commercial deployment launch and the approval of the SASs, which led into the early part of 2020 with our full commercial service launch at the beginning of the year. And then, of course, we continue to do work in the background here to enhance our specifications and to include 5GNR into our specification portfolio. Another major item that, if you've been following the CBRS world at all, that you've been seeing is about the PAL auction. The PAL auction the auction phase has concluded, and we're looking forward to learning who are the folks that have invested in the spectrum. And I'll talk a little bit about what that layer in the spectrum sharing looks like as well for some context. Next slide. So again, membership of the Alliance, what you see along the top here are our board member companies, including Boingo, Ericsson, and others. In addition, you will see what has become a little bit of an eye chart, which is a good problem to have for us, and that is the list of members from the carriers to the cable operators to equipment vendors to ecosystem partners to end user equipment developers. This is a very diverse ecosystem of member companies that we see represented here, which really brings a lot of great context and information for our members in their discussions, so that we can make the most and the highest value really out of the work that we are doing. Next slide. And I should mention Commscope. I mentioned the other company, so my apologies. Commscope, also one of our key board members here. So the inaugural year, we talk about that really, between 2019, 2020, this last 12, 13 months has been extraordinarily exciting. And since the full commercial deployment was announced, what we've been seeing is tens of thousands of CBSD deployments, all types of devices, indoor and outdoor, all types of use cases addressed. Of course, there's large numbers getting started with fixed wireless, but we see that as a stair step up into the other types of use cases that we're expecting. What you also see on this slide is some representation information about our ecosystem. And this is growing so rapidly, it's hard to keep this slide up to date. what we're seeing is a large number of authorized models of the Cbsds. These are the base stations, the access points, the infrastructure side of the network equation. And you see here 103 authorized client devices. So these are the end user devices. This number is even larger as of yesterday. So it continues to grow, and we're starting to see exponential growth in the number of client devices. We're in that phase. There are 5 authorized spectrum access system administrators. We'll talk about them a little bit as well. And now I believe we're knocking on the door of 2,000 certified professional installers, maybe just slightly under that at the moment. And then, of course, as mentioned earlier, we are working diligently right now on the 5GNR specs as part of the 3.5 spectrum sharing in the CBRS band. Next slide. So again, a little bit of history. You will see some terminology here, and you'll hear terminology if you're not as familiar with this space. You will hear Part 96. Part 96 is not really code. It's just a simplified expression for the portion of the CFRs, the Code of Federal Regulation, where this particular band and the sharing requirements are detailed. If you'd like to learn more about that, you can search the FCC site, probably put in just Part 96 and it'll get you to the right place. But the full identifier of where this is located in the CFRs you can see as well. We partner very closely with our sister organization, the Wireless Innovation Forum, that you'll hear referred to also as the WIN Forum. And we work with them very closely. What you see here is some of the responsibility layers between Wireless Innovation Forum and the CBRS Alliance. So Wireless Innovation Forum is really the standards development body for CBRS Alliance in some respects. They develop the requirements for SAS, the testing for SAS, also what are the interoperability requirements, and they are technology agnostic. So the band, by definition, is not dedicated to any particular technology, any particular radio access technology. And therefore, WIN Forum looks at this from that point of view. What CBRS Alliance does is focus exactly and primarily on LTE and 5GNR based solutions in the band. So we become much more specific in that sense. We develop the technical requirements when it comes to the interoperability for LTE and 5GNR in the band, and we run a certification program for at the moment, the infrastructure side of the network equation. Next slide. So just really quickly on the tiers and how this spectrum sharing works. What you see at the bottom is the the band that we were talking about, 3.55 to 3.7 gigahertz, and you see the 3 tiers. You see GAA at the bottom, PAL at the middle, and the incumbents at the top. The incumbents are primarily military radars, ship-based radars. There's also some ground-based fixed satellite stations, and you see the WISP, wireless internet service providers, listed here as well, but shaded. That's because the WISPs are in a transition period from being an incumbent to being part of the 3-tiered spectrum sharing in either tier 2 or tier 3. So they're making a transition as we speak. The 2 tiers that you see that are of the commercial deployments, the bottom is general authorized access. This basically means it's open. It can be used for any purpose as long as it follows the rules laid down in Part 96, as mentioned before, and that the infrastructure is connected to a SAS. The PAL, or Priority Access License tier, basically this is the auction that has just concluded with the FCC, and this is one step up in the prioritization table. There are 7 10 megahertz licenses per county in the United States. That's the auction that just concluded. And what the PAL winners essentially will have is prioritization in the sharing. So if there is a decision in between GAA and PAL, the PAL will get service. The GAA may be asked to move to a different channel. Everything, of course, is has to be responsive to the requirements of the incumbents. They are always the ones that get the spectrum if they need it. Next slide. So one of the things that we've been very pleased with and very fortunate in is the cooperation between the various government agencies and the industry, in this case, represented by the CBRS Alliance. So what you see here are a couple of quotes from key folks in NTIA and the FCC. What you see below is Chairman Pai's comment at the beginning of the year, and you know, the success that we have enjoyed in having that relationship and that close cooperative relationship with FCC, with NTIA, Department of Defense, etc. Next slide. Next slide, please. You guys still hear me okay?
Yeah, we can hear you. I did change the slide though, Alan.
Okay, I'm not seeing the update on my side, so there it is. It just updated. So learning the lingo, this is where the description between OnGo and CBRS Alliance comes in. So CBRS Alliance is the organization that we represent here. OnGo is the brand name for LTE and 5GNR in the band. So you talk about OnGo as a name, as a branding as a descriptor for LTE 5GNR in the CBRS band. CBRS as a term is really about the FCC ruling. It's about the band. It is a descriptor for the things that came out of the FCC's rulemaking. Next slide. There may be a little delay apparently on my side, perhaps, for the slides, but I think.
Yeah, it looks like Steve is up.
Alan, I think I'm up.
My apologies. I don't know why it's updating very slowly on my side. But Steve, I'll turn it over to you, sir, and we'll go from there. Thank you for being here, first of all, and please take it away.
Thank you for having me. And one thing I would add to your introduction, you mentioned a couple times that the auction has concluded. I would add that it concluded with 4.6 billion in bids, yeah, which I think is on the higher end of expectations, is a great sign of, first of all, the success of the CBRS Alliance, and also just the general interest and the excitement around CBRS. So congratulations all around.
Yeah, very good. Thanks for mentioning that, Steve. That's a very good point.
It's a really, it was a great auction, I think. Next slide, please, Josh. So this is this webinar is to talk about use cases in transportation, and there have been a number of other CBRS Alliance webinars for other vertical market segments. I'm actually quite excited to be here talking about transportation. I think it's a great vertical market to talk about the unique capabilities of CBRS and OnGo certified solutions for private LTE use cases. When you think about transportation, and this is airports, shipping ports, railroads, highways, light rail systems, these are all very, they're typically large facilities, asset intensive, a lot of money involved. It's very important that they run efficiently, and that people have to be empowered to run the systems and get the most value out of them. Very large spaces, often not well covered by mobile operator services, and really often just too big to cover very well with Wi-Fi. Something new that we'll see, probably you'll hear a lot about in these use cases, is there's a lot of new IoT opportunities, Internet of Things. And these are enabled by new devices, new cloud systems and dashboards. But again, you can only deploy IoT solutions in the transportation sector, if you have a solid connectivity solution to bring all that information back to the network. So it's very, very critical across all these market segments within transportation that they have a solid wireless connectivity. And I say wireless because both a lot of the assets and the staff are highly mobile. There's not a bunch of people sitting at a desk. They just need, untethered wireless connectivity wherever they might be. And finally, I'll say there is a lot of commonality across the different transportation market sectors, but each of the individual sectors will have unique use cases. We're not going to cover all of them today, but hopefully between myself and the two other speakers, you'll get a good sense of how CBRS can be effective, especially effective in transportation. Next slide, please, Josh. Just as a quick refresher for anyone who's new, I want to just highlight why CBRS is such a good solution. And I'm going to do that by comparing it to the two legacy wireless options that enterprises have. Historically, there's been either Wi-Fi, which most people know about, great solution, or mobile operator LTE services. And again, you're all familiar with these. CBRS, we like to think it takes sort of the best of both worlds. We're not necessarily competing with either one. Obviously, there will be some overlap, but for the most part, CBRS is a new platform. It enables new capabilities, and the more we can promote how it fits, how it compares, I think it's going to be easier for all of our customers to understand where to apply it. So let me compare how CBRS, what are the advantages versus Wi-Fi? And I'm a longtime Wi-Fi person. We like Wi-Fi. Wi-Fi gets better all the time. It's continuing to improve. But regardless of that, CBRS, running LTE or soon 5G, it's always going to be a better, more reliable connection. It's centrally managed. There should be very little interference because of the SAS, because you have dedicated spectrum. So it's going to be a better, more reliable wireless connection. It has a much, much better range, which is especially important if you're like an airport or a railroad yard with a very, very large area. You just can't cover that effectively with Wi-Fi. Just putting up all the access points it's too expensive, too hard to maintain. There's great security. In CBRS, we use completely standard LTE. You just can't deploy it without great end-to-end security. And it supports mobility. It's just baked in. You don't have to do any special configuration. And again, if you look at an airport, there's a lot of vehicles driving around on the tarmac out there. Same thing with the rail yards, same thing with shipyards. So CBRS is a better solution than Wi-Fi for some of these critical operational use cases at very large transportation facilities. Similarly, if you compare CBRS to mobile operator services, mobile operator LTE and again 5G, great services, essentially ubiquitous coverage, but often they don't provide great coverage of transportation facilities. And one example I'll give is a railroad yard. It's on the edge of town. It's relatively low user base there. The mobile operators, it's not in their best interest, from a financial perspective, to ensure they blanket that with the best possible connectivity. It's sort of an afterthought. So if you're running one of these transportation facilities, you might not be getting the great coverage you need from the mobile operators because you don't have control. And then you also have the issue of having to pay for each additional device that you're running over the network. You don't get any of the user information about who's on the network, how long they're on it. All the information that an enterprise would get from a Wi-Fi network, it's not available if you go through a mobile operator. And finally, in some use cases that might be very latency sensitive, if you're using a mobile operator service, all the data goes up to their cloud, has to come back. That adds latency. With CBRS, you have the flexibility of putting in an on-site EPC or a local breakout for the data, and you can achieve very low latencies very easily. So we think CBRS is a good complement to Wi-Fi and mobile operator services, not trying to replace it, but ideal for transportation. Okay, next slide, please. So first one I want to talk about, and this is an active opportunity. A major U.S. airport is looking to deploy a new IoT solution for all the ground operations on the outside of the airport. So this is a huge airport, multiple runways, very limited mobile operator coverage. Again, as I said, way too much space to cover with Wi-Fi. And they are looking to deploy an IoT solution to connect all the vehicles. So there's fuel trucks, there's food trucks, there's baggage handling, there's security, there's all sorts of cars and trucks running around outside the terminal on the runways. They need to track where those cars are, be able to dispatch them, be able to track the movements, even enforce geofencing. So if some vehicles in a place it shouldn't be, they want to set off alarms right away. CBRS is a great solution for that. In this case, they're looking at over 20 Category B access points, the high-power CBRS radios. There's 1,200 vehicles they're going to be tracking in the initial rollout. So a huge deployment, and CBRS is a key enabler. Another thing, since CBRS is a broadband solution, every one of those vehicles is going to have this LTE router, which will be a Wi-Fi hotspot. So all those staff members will be connected. They'll have great network connectivity wherever they are on the airport facilities. Next slide. Another one, and this is another very interesting one we're working on. This is with a state Department of Transportation, and they do a lot. There's actually a lot of different use cases, but in this case, we're working on with their construction team. So every road construction project, they set up a crew there. They often set up a construction trailer, and these projects might last 1 or 2 years if it's a big project like expanding an interstate or adding a bridge, and they need connectivity on site. And what they're very excited about CBRS. Currently, they're doing Wi-Fi, and they use that to connect video security cameras and provide some on-site solutions. They're also using land mobile radio for push to talk, and they use mobile operator services. But the vision they have is with CBRS, with just 1 or 2 access points, they can cover most construction sites. They can have their own dedicated secure network, very easy to set up, very secure, and they can support all their applications. So again, another great way to demonstrate CBRS. Josh, let's go to the third slide. I'm just about out of time here, so I'm going very quickly. Large railroad, this major railroad in the U.S., we're focusing on the railroad yards, and railroads today, they actually still do lose rail cars. So if you look at that picture, they're a very dense area with a lot of metal boxes, large space, and they need to put in asset tracking, so they not only know where the trains and the cars are, but they want to also get better information to the people working on the rights of way, the people working on the track, who need to know what windows of time they have to be working on the track before they have to clean up and get out of there because a train is coming through. So again, this is an area it'd be impossible to cover with Wi-Fi. With CBRS, they can blanket the entire, say a 300-acre train yard with just a few access points. And this allows the railroad themselves to ensure they have the wireless communications platform that they need to support a range of devices. It might be smartphones, might be push-to-talk phones, a lot of LTE routers, all sorts of devices, video cameras, to empower the railroad to run much more efficiently. Josh or Alan, back to you.
Very good, Steve. Thank you very much. Very interesting. So our next speaker is Dr. Derek Peterson from OnGo Wireless, and Derek joins us from the wilds of Utah today. So thanks, Derek, for being here. I'll take it away, please.
Hey, it's great to be here, and as shared, I'm happy to be here and be joining you and Eunice and Steve. I think the key thing is I'm going to be trying to talk to you a little bit about what's going on in the world and how the airports and other transportation areas are having to adapt how they think about it. 2020 has been a disruption for all of us with this COVID-19 and all the challenges there, and especially for the transportation industry. We've been, as a OnGo, we've been providing both cellular and Wi-Fi connections for both customers as well as the staff at airports since early 2000s or late 90s. So we've been involved in that digital transformation that they've been making, and this disruption that's happened with COVID really has caused this digital transformation to kind of have to accelerate, and also look at new opportunities to be able to make the environment safer for others as we gear up and start traveling more. So let's go ahead into the next slide there, Josh. So, you know, one of the things that I said is that the airports do want to reopen, and it's important for us all that the airports do open. There's work to be done, people to travel, weddings to go to, opportunities that we've been missing out that we really need to go back to, really just enjoying our lives. And one of the key things to do that is we need to focus in on how to make the airports more safe, and what are some of the aggressive health and safety steps that an airport can take to make sure that the passengers and the staff members who are operating in these highly enclosed environments and busy environments in a safe way. So there needs to be a sharp focus on preventive measures that you can take, where technology can assist as the common denominator for creating what we're calling the touchless passenger journey. And so it's very important. And the key thing there is OnGo is a big part of that. Airports can turn to this technology. They've got Wi-Fi and cellular at most of them technologies, but they need an extra connections. The ability to control those connections, as was shared, is an important part of what they want to do as well. And so the OnGo technology allows them to kind of reimagine that new travel experience and have a little bit of control over how they're going to reimagine that. Still use the Wi-Fi for everybody else in the airport, still use the cellular for all the cellular customers and those connectivities, but then add additional digital transformation touchless experiences taking advantage of OnGo. And I'm going to dig into that a little bit in the next slide. So please, Josh. So before I get into how OnGo solves that, let's talk about some of the challenges. First, there are 3 core challenges that an airport's facing right now. They want to make sure that they're thinking about the health and wellness of the staff and the people coming through that venue. They need to make sure they're all safe. They need to communicate the changes that are happening. As we've all experienced, there's different ways we walk around an airport or shops that we go to today. We're trying to keep those 6-foot markers between us to maintain that distance between each other. There's signage that needs to happen. There's this idea that we need to wear masks when we're around with each other, and so we need to maintain that communication that says, please wear a mask and stay that. And really, that communication part is a key element. And so having that communication and being able to digitize that is also an important part of it. And finally, there's monitoring that needs to happen. We need actionable data that we can look at. We need to understand when people are moving, how they're moving, where they're moving, so that we can make sure that we're providing an easy way to be able to provide paths for people in this new social distancing way. And a good example of it is I was watching my kids get on the school bus the other day. Here they get to go to school, but they have them standing in line 6 feet apart, and they're finding new ways to try to speed up that process, because it took 45 minutes to get everybody on the bus and socially distanced. Those are the kind of things that are important that they're going to happen inside airports as we start opening, is trying to find that way to be able to create those environments. So creating that touchless experience, next slide please, Josh, is really about understanding those challenges that we're facing. So those 3 main challenges: health, communication, and digitizing and that. So after we address these challenges, in this slide, what we're seeing is the connectivity solution that you can bring to bear to solve that, whether it's monitoring, communication, or health. And so you can see there's examples of cameras and sensors, and I know Steve talked about some of that when we're trying to keep track of vehicles and where they're going in buses and all of that information and those connections that are happening, and to allow us to know where a bus is, when that bus is pulling in, how to be able to quickly get them off, all of those things that happen at an airport. Those cameras and sensors today could be provided through a wired internet connection or a Wi-Fi connection. But in addition to that, we can use private LTE on OnGo. All right, so that OnGo private LTE solution gives you that tested and true connection so that you know that you're going to have a good connection all the time because you're getting dedicated spectrum and you're in a managed environment and you're not having all of the Wi-Fi connections that you're going to have and interference that you're going to have possibly by all the people trying to connect and get their emails and everything else that they're trying to do with those Wi-Fi services that they're using on their devices. And so it's important to have that extra security of that PLT connection to be able to deliver that information to your operations staff so you can provide a better experience. And so it's a very important, so I've got a couple others we can talk to, push to talk devices or another very common first responder and staff solution that's great with PLT or OnGo. You know, a lot of the solutions again today are using cellular, but again, the advantage to using private LTE or OnGo is that you end up owning that spectrum, you end up owning that enablement, and you end up having a little bit more insight than you would traditionally have if you were having to either use or lease from an MNO or an MSO or some other licensed carrier who's providing that service for you. So a lot more ability to be able to customize it for your needs. There's others there. I'm not going to go through them all just for use of time, but very important for us to realize that if you look down this connectivity solution, you can see that in a lot of these use cases that we've highlighted, PLTE and OnGo is a very important part of the solution. And so improving that and adding OnGo into your airport environment or your transportation environment is something that everybody should be considering and thinking about right now, especially now that the auctions are over and it's time to get rolling and get these installations done. So on the next slide, one of the things that we need to recognize then is that there's going to be an unrelenting increase in mobile data traffic. So combined with 5G, IoT, and now these COVID demands, we're going to have a very complex wireless environments that airports are going to have to look at and they may seem daunting, but it's important for them to realize that a converged network with Wi-Fi and cellular and all of these other technologies that I've listed on this slide, 5G, LA, et cetera, it's going to be very important that they prioritize this convergence and prioritize putting OnGo into these environments and understand the use cases that they want to use this technology for. And so another thing that's very important is realizing that connectivity will not be a one size fits all. Every environment's going to be a little bit different. That converged approach requires you to think through what devices you're connecting. Are they OnGo capable? Are they Wi-Fi capable? Are they cellular capable? Hopefully in the future, everything's all capable of all of those technologies. But now, you know, there's going to be some consideration as you're putting through your thoughts on how to solve use cases that you're going to end up having to think through those, and then the cost of adding a dongle or an additional spectrum capability on a camera through a dongle or through some other things. How are you going to do that? What's the cost effectiveness of that in your environment? And then which technology to use and how to take advantage of CBRS in a very economical way, and Wi-Fi and cellular and all of those other technologies. And one of the key ways, so next slide, Josh, to do that is to really just start thinking out and prioritizing your needs. Remember that revenue is going to be a big part of your decision. Efficiency is going to have to be thought through of each of the technologies and how they can solve the demands for today, but also for your future plans. As we move to more and more touchless experiences, we're going to have touchless ticketing. We're going to have hopefully touchless TSA, and you can go through there very easily, and it's going to end up providing a clean environment for us to get that done. So all of these are going to end up allowing us to basically reduce that cost, share the resources across all of these technologies, but also create that digital transformation that's key for that airport. And given the need for all of these different technologies, one approach for this is looking at that neutral host approach and realizing that it's increasingly important to get all of those technologies thought to together so that you have that shared environment. you have all those spectrums, all those bands, you have a consolidated way to look at how it all works together. And then you approach it by sharing equipment, sharing resources, and sharing it across not only environments that you own, like OnGo and possibly your Wi-Fi, but also environments you don't own, like the licensed carrier environments that are part of your networks today. And it needs to be layered in a cybersecurity architecture to protect all of the data and all the safeguards. So you've also got to think through all of that, and that's a key part of developing your full architecture and pulling in that help that you might need from a neutral host approach to be able to meet that. Next slide, please, Josh. So I got the last couple of slides. I think the first thing is you know, it's going to take a while. Connectivity is complex, and what's going on in our world is complex right now with this disruption. But together, I know we can solve this. We can end up coming up with models for the best way to approach deployment. And one of the ways we're doing that is Boingo, one of the guys who work for me, Nart, leads up right now this deployment and operations work group at CBRS. And what we're doing in that group is we're trying to think of the best way to be able to deploy all these technologies together. And we've laid a foundation to help others understand how to deploy this, the right ways to deploy the technology, how to deploy it in a combined way, and how to really get OnGo out there and be a part of the solution that we're trying to create. And so I really encourage everybody to come in, join that discussion, help us find that right recovery mechanism for being able to get us back to traveling like we have done in the past. We have a ways to go, but we can recover stronger than ever as we work together and we rebuild and design this next area of travel with this new technology with OnGo. And of course, above all, I really believe that travel is important. It's an important opportunity for all of us. It lets us see our loved ones and everything else. So it's important for us to work together and focus on that. And it's really an opportunity for us all to heal as we create these environments to do that. So every airport operator, if there's any airport operator out there listening today, let's get together, let's work, join the CBRS Alliance, help us define what you need, and let's get you set up so that you're ready for returning to normal. So I got I think that's it. That's my last slide. I'm going to go ahead and turn it over to Eunice. So thank you, Alan.
Yeah, very good, Derek. Thank you very much. And it's now my pleasure to introduce Eunice Shadad. Eunice, please take it away, sir.
Thank you. It's really good to be here. I'm really excited today to be sharing a case study where we deployed a major private network for a major airline here in Europe, and I'll discuss as well the solution, how that was selected. Before coming here, I actually had a great opportunity to meet with the team that actually deployed this specific project that we're talking about with Air France and the Paris airport. Next slide, Josh, please. So let's set the stage with the challenges that had to be addressed. We had a faulty intermittent legacy mobile communication system here at this airport called Tetra, servicing this airport, including flight operations, safety teams, logistics, freight, but lots of interference, like Steve mentioned earlier, and reliability issues. And this is no small airport. We're talking about 120,000 users, 70 simultaneous flights, a massive operation. There are major requirements of high security and low latency applications and increased use of video. And in this case, Air France actually applied for the use of a private band from the French government along with other 12 companies. And they got approved and subsequently entered into a sharing agreement with the airport represented by Hub One, which is like an MVNO at this airport facility. So let's think about things here: technology, quality, and investment. Starting with the technology, we're talking about Cbg Airport that was operating within a mission-critical and complex environment. What does that really mean? The complexity comes from the fact that you have multiple systems available at this airport. Wi-Fi, another one for Tetra, and perhaps a few more. Always an area of focus. And not just was voice free of noise, but they now wanted to take that to the next level with high definition voice and high data speeds. And of course, the definition of high was evolving and based on the technology that would would support that those data speeds. The use cases that one could drive with that technology was a major area of focus. For all this to happen, Air France needed a really good ROI with lower total cost of ownership than what they had before, and not to mention new revenue streams. And the solution we deployed was a fully dedicated private network using radio dot for the airport on 2.6 GHz. Call it the CBRS band for the French government. And we deployed it using a proof of concept approach where every step of the way was scrutinized by multiple stakeholders. It was airport itself had a very highly competent staff due to their experience of Tetra. As such, they were very demanding of excellence in execution every step of the way. The private network, though deployed by Air France, was shared with the entire airport, even with the competitor airline terminals. And as expected, CDG was very happy with the results, and they expanded it to the other small airport that we had in Paris. Net, the result was a fully connected, intelligent, and yet operationally efficient airport, delivering that rich experience to everyone, passengers and staff alike, ready to take on the digital transformation of the next generation airport network. At a high level, the future of Cbg Airport can be categorized into three different areas. First, cost reduction. Almost put to steroids now with this COVID-19 situation that we're in. Second, digital transformation. And I know Steve kind of referenced that a little bit earlier. And third, the revenue creation. Let's take the first one. We're not just talking about reducing the operational cost, but avoiding delay penalties while improving security, directly or indirectly impacting the cost. For example, a top-tier airline paid over $1 million for a tarmac delays. Another example of artificial intelligence that takes data from across the entire CDG airport operations to visualize, simulate, and predict what will happen next. Integration and enablement of information sharing between management systems from flight and terminal operations, passengers, luggage, cargo applications, government agencies, ground entities, and so on. All of this put together has given Air France and CDG the opportunity to reduce the cost directly or indirectly. In addition, CDG is not just one connected airport. It has begun the journey of being part of a larger ecosystem of connected airports. So when we talk about digital transformation at this airport, Air France and CDG have an opportunity to create that digital relation with the passengers. As an example, we have many opportunities at this airport now, like an automated security with no physical checks with passengers and baggage recognition. We can have travel approvals and custom checks that can be made in advance of a flight, saving time at the airport with remote baggage drop-off and collection. We can have much deeper understanding of the passenger mobility patterns, which can help Air France and CDG with the monetization, and have, we can have connected and autonomous vehicles and robots that can all set to be the commonplace throughout this airport. So while cost reduction and digital transformation, all help the ROI, we now have an opportunity as well to create those new revenue streams with new use cases, transforming this airport into a smart city. High-speed multimedia kiosks for travelers to download videos before they take a flight. No boarding passes where government agency or airlines can simply scan the face of the passenger and use this network in lieu of a boarding pass. Another interesting example could be a limo service where luggage check-in at the home or at your hotel or your office with auto approve and facilitation for regular travelers and many other location-based services as well. Josh, next slide, please. So now that we have what we achieved, at Cbg Airport, let's understand the criteria that was used to select the solution at this airport and perhaps to other future airports. It all starts with a clear understanding of that monetization plan that we just discussed. Once we have this plan in place, the first thing we do in most cases, the most precious variable, as I call it, is the space. Space in the head-end room, where we have, call it, for lack of a better word, hotel of most network equipment, a mini version of that, which is the IDF closets, and then as well the space we have in the risers. So we can have the best solution and all the money to buy it, but if we don't have a space, it's a non-starter. So what's also important is the deployment experience. It counts a lot when it comes to the airports. Having done that and been there before, delivered on time without delays, and having the resources, the tools, and the methods to execute those projects flawlessly is absolutely critical for this particular vertical, more than any other vertical when it comes to private networks. We absolutely cannot afford to take any missteps here. From a capability perspective, the 5G, the IoT, and the location-based services, which have accuracy of within 5 meters, becomes increasingly important when we map these capabilities to airport requirements of the future, particularly the use cases and the monetization plan that I referenced earlier. In doing so, we want to be able to deliver an outstanding subscriber experience, with the most important KPI being that downlink throughput, more than 1 gigabits per second, with a very high capacity. What I mean by capacity is the number of users and unparalleled security to go along with it. Now, having covered the monetization plan, the deployment aspects, the capability, as well as the end user experience, it's essential to make sure that our costs are in check as well. Now, more than ever before, we have an opportunity to reduce significant costs by removing some of the active DAS gear that many airports are used to from the past deployments. Make it much more like an IT type of deployment. Reduce those significant costs of cabling with the IT type Cat6 cables versus the coax cables, and create that deployment efficiency and predictability in the cost that most of us will need to make such an investment. What's also important here to mention is not just the current costs, but also the future costs of upgrading the technology, adding capacity. If we can keep those future costs to a minimum, it's like more than icing on the cake. So what are we talking about? If we need to add, let's say 5 to 7 years from now, 10 times more capacity, 5 times more capacity, we need to be able to have the ability to do it with a few stroke of commands, instead of having to visit the site and recabling and adding a lot of equipment. That is what we're talking about, and that is huge. If we can go and add that capacity without that intrusion, and if we can even upgrade from a 4G network to a 5G network without those intrusive activities at the venue, more at airport than anywhere else, that's huge. And there you have the process by which we want to have that right solution selected for these airports. With that, I'm turning it back to Josh and the team.
Very good, Eunice. Thank you very much. Very interesting. So we have about 5 minutes for questions. We've gotten a few questions in. I think some of them are pretty lengthy, so we're going to take some of those offline. and do some text answers so that we can be fairly complete with them. But maybe I could open up to the panel, ask you to join me back on video here. And you know, one thing that I think is on a lot of folks' minds is, you know, this is shared spectrum. You know, the term that gets used is this is a shared resource. How do we make sure that everybody, you know, has access to the shared resource? What happens if things get a little bit more congested and a problem that we would like to have? But you know, how are those kinds of issues managed to allay fears of our guests?
Oh, I think Steve's our SAS guy here, so why don't you take this, Steve?
I'll try. Actually, I'm on the infrastructure side from Commscope, but I think it's a consideration you have to look at for any deployment in CBRS. Do you need a GAA or a PAL license? And we really think for most use cases, transportation facilities should be able to get by with GAA licenses. I mean, the consideration is, does a use case, is it absolutely, you know, critically essential that you have, you know, nonstop connectivity? I mean, if it's flight landing operations, then you might have a little bit more of a concern. But fundamentally, these are very large facilities, and even if someone has a PAL license covering your, say, your airport, that spectrum is yours to use unless the PAL license owner deploys a network covering the airport. As the airport owner, you can control who's putting, you know, facilities in there. So we think the SAS would protect the airport for their own private network, and they should get plenty of spectrum there. Certainly inside the terminal shouldn't be an issue. Close to the terminal shouldn't be an issue. Maybe on the fringes on the far side of the runway, there might be some overlap with maybe someone's got a category B radio, but the SAS has mechanisms where they can, say, turn down the power, or, you know, ideally just move people to non-overlapping channels, or they can turn down the power. So we think the vast majority of transportation facilities ought to be good to go with GAA.
Yeah, Steve, thanks.
Yeah, if I would just add a little bit, you know, I think that key that, you know, the SAS is one of the advantages of, you know, OnGo is that we're going to have the SASs. It's you're registering with the SAS saying that you're there. So you know who else is going to be there with you operating those frequencies. Unlike with Wi-Fi, when anybody can turn on a hotspot on their Wi-Fi and then you have the interference, which is why you have to do listen before talk. Because you're using LTE technology, it's a managed spectrum, so you're managing it. And you'll know who, because everybody who wants to operate in that area has to register. They're going to register with that SAS, and you'll know who's in that area. So then it's just a matter of coordination, working with each other. If there is any time that we get too much use, which would be a great thing to have, as you said, Alan. But if we get there, then you know who to reach out to and who to coordinate with. And there is a coordination mechanism there, which is great. Something that, you know, unfortunately we miss in Wi-Fi because it's a undeterministic spectrum. This is more deterministic, so you have that opportunity to work through those challenges with each other if they do arise. But I agree with Steve, you know, the likelihood of them arising is kind of small because, you know, the real estate agent, the airport in this case, or the train station or the railroad station, they own that real estate and they own what equipment gets installed on that real estate. And so they're also going to know through that means of what's installing and what spectrums are being used and who's using them, because they're authorizing the construction on their facilities.
Great, thanks, Stuart.
And just to add to that, I think what we can also say is, you know, with the control aspect, even with the part where the GAA, we have seen data where we can command up to even 1 gigabits per second or greater, even with the GAA part of the spectrum that's used. So that, I think, is quite exciting for us in terms of that end user experience, which is what this is already about in many ways and less.
Exactly. Well, gentlemen, thank you very much. We are up against our time. We did get some additional questions. We will share those with you all. Work on putting some text answers together, and we'll include that in the upload of the information that we put up on our website. Also, just to make everyone aware again, we will have the one-pager on the website as well as a recording of the webinar that you can share with your colleagues. But I want to say a hearty thank you to our panelists today. Fantastic job as always on our panels, and especially gentlemen with your insights on transportation. So thank you very much.
Thank you all.
To everyone else, I
Thanks, Alan.
appreciate your attendance. Thank you very much as well. I wish you good health. Everybody stay safe, stay well, and join us again for future events. Thanks, and good afternoon.
Thank you.